This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software.
Welcome to Software Engineering Radio. I'm your host, Gavin Henry, and today my guest is Karl Wiegers. Karl Wiegers is Principal Consultant with Process Impact, a software development consulting and training company in Portland, Oregon. He has a PhD in organic chemistry, which we'll touch upon later. Karl is the author of 13 books, including Software Development Pearls, which we're going to talk about today, The Thoughtless Design of Everyday Things, Software Requirements, Successful Business Analysis Consulting, and a forensic mystery novel titled The Reconstruction. He has delivered hundreds of training courses, webinars, and conference presentations worldwide. Karl, welcome to Software Engineering Radio.
Well, hi, Gavin. Thanks very much for having me. I'm happy to be with you today.
So I'd like to start with a brief history of your background in software, and then I've broken the show up into hopefully 6 blocks of around 10 minutes each so we can dig into various sections that I found good in your book. So we'll see how we get on. We'll do our best. So first of all, I'd like to address the fact that your book says 50 years of experience. Has that been a volatile 50 years of change, or was there more or less change during certain periods? What stands out for you during those 50 amazing years of career?
Yeah, it's hard for me to believe it's been that long. In fact, it was 50 years when I started writing Software Development Pearls. I first learned to program in college in 1970, which is now almost 52 years ago in September. And I did a lot of programming in different situations there and also in graduate school in chemistry at the University of Illinois. I did a lot of software development for various reasons and started out my career at Kodak in Rochester, New York as a research scientist. And then after a few years, I moved into full-time software development. And what was interesting is I also became an Atari hobbyist. Remember Atari computers? Maybe you're too young for that, but I was an Atari hobbyist and I did a huge amount of programming at home and even wrote the assembly language tutorial column for a hobby magazine for 2 years and even programmed some commercial educational games. So I did a lot of different kinds of things in software. I moved from software development into software management and then into a more of a quality engineering and process improvement kind of role and started my company Process Impact in 1997. Plus, of course, like all of us, I've got a lot of experience as a user. And, you know, a lot has changed in the last 50 years about software and software engineering. But one thing I think that's interesting, Gavin, is that some things really haven't changed as much as you might think. For example, requirements development. That's an area I've done quite a bit of work in. That's not really a technical problem. That's a communication problem or a thinking and business kind of problem primarily. So a lot of the challenges that people faced with the requirements long ago are still valid.
That leads us nicely on to the first section of the show. So you mentioned requirements, which is spot on for where I'm going with the show. So in lesson 4 of your book, you say, a user-centric approach to requirements will meet customer needs better than a feature-centric approach. So I think that is understanding or trying to understand what they want from something rather than the features. Could you explain that better than me and take us through that?
Yeah, there's 2 separate but related concepts here. You know, the first is user engagement. Okay? And I think we all talk about users, but sometimes I don't think we do a good enough job of understanding who our users really are. So I think it's important to do some stakeholder analysis and then identify your user classes. User classes being distinct groups of users who have largely different, maybe not completely orthogonal, but largely different needs and tasks they need to perform with the system. So we did that for an information system project I worked on at Kodak called the Chemical Tracking System, where I was the lead BA for the 3rd attempt to get this project done. The first 2 had failed for some reason. And we identified 4 distinct user communities with largely different needs. So that's a good start, but then you have to say, all right, so who do I talk to? Who do I get requirements from that I can trust? And so, in other words, who's going to be the literal voice of the customer for each of these groups? So when I was at Kodak, we started this idea clear back in 1985 of having product champions, was the term we used, for key representatives of each of these user groups. And those were the people that the business analysts would work with to try to understand their requirements. And then we get to the second part of that question about usage-centric versus feature-centric. which is to focus on understanding what users need to do with the system, not just the features they want to have built into the system. And what we're doing, and this was a really profound moment. You asked earlier, Gavin, about times of change in the last 50 years. And one of the really profound changes in my thinking about software engineering was when I realized, first of all, that there are different kinds of requirements, which I classify very broadly. There's business requirements, user requirements, and functional or solution requirements. But then the real insight I had was when I learned about use cases. And I realized that if we talk about what people need to do with the system, we learn a lot more than if we just ask people, well, what do you want? And the first time I applied the use case technique was on that chemical tracking system, which the previous business analysts had not managed to get anywhere with. And it worked remarkably well. All of the user representatives we worked with really found that approach comfortable and satisfactory and natural when we're talking about, well, what are the things you need to do with the system rather than what the system should do itself. So I really got sold on use cases and this usage-centric thinking.
And does that fall under any type of model that is given a name today, a type of practice or something, or is it encapsulated in requirements?
Well, that's a good question. I think the use case rubric overall, I think, is kind of the overarching theme there. And you do hear people talk about use cases actually in daily life sometimes now, even though I'm not sure they're using the term exactly the way we do in software, but the same idea. And the reason I think this is so important, so I'm not sure there's a general methodology, but if we focus on that idea of usage-centric requirements exploration and usage-centric design, it solves a lot of problems. If you ask the traditional question during requirements discussions, what do you want? Or what are your requirements? Those are terrible questions. What they do is they open the door, and maybe you've had this experience, you just start getting this random pile of information that's really hard to turn into a set of useful requirements that leads to a decent solution. And also another thing that happens, you can focus on features so you implement functionality that doesn't actually let users do their job. Or you can implement functionality that no one's ever going to use, but you work pretty hard on building that even if they don't use it. So that's pretty discouraging too.
And why do you think this normally goes wrong even today?
Well, I think it goes wrong if people, A, aren't talking to the right representatives who can really represent the needs of a community of users, like a particular user class. It goes wrong if we leave it so open-ended and just ask people what they want and they free associate and they think, well, it should let me sort this list this way. And then you miss the gist of, well, what is the task you're trying to accomplish? And one way that I try to phrase that question is think in terms of, okay, so here's an app. You're going to launch the app. What are you trying to accomplish when you launch a session with the app? You're not launching it to use some feature. You're launching it to get something done. Even if it's a game, you're trying to get something done. Or if it's a device or it's a software application, you launch it for a reason. So by trying to understand the reasons people are using it and what they're trying to accomplish, then we go a lot more to the right side of understanding, all right, well, what functionality do we have to build to let you do that? And are we sure that that all aligns with our business objectives? So it goes wrong if you don't take that kind of approach. And I can give you a great example. So I've been a consultant for about 25 years. And one of my consulting clients once held a big one-day off-site workshop. They had about 60 participants, and they called this a requirements workshop. Broke them into 6 subgroups and to collect what they considered to be requirements for a big product this company was working on. It was a commercial product. So they took all the output from those 6 subgroups and basically stapled it together, literally and verbatim, and said, well, here's our requirement specification. But it wasn't. That's what I call a pile. There were a lot of useful and important pieces of information in there, but it wasn't structured or organized in any useful way. Everything was stirred together. There was a lot of extraneous information and ideas and thoughts just all thrown in. So by just asking people to brainstorm what they wanted didn't produce any actionable requirements knowledge, although there was probably a pony buried in there somewhere. But that form of having the conversation didn't lend itself to getting the information you need to say, okay, what is it we need to build?
If they did take that big pile of stapled information and then came back with something weeks or months later. That's your traditional waterfall with no requirements engagement at all, isn't it?
Yeah, and it's even worse because you started with a really bad bucket of water to dump over the waterfall at the outset. So I think what we really want to try to do, besides having the ongoing customer engagement, rather than just trying to do it once at the beginning, we all know that doesn't work real well. And I think having ongoing touch points throughout the project is really important. But by asking the right kinds of questions and then taking the information and organizing it and structuring it in a way, and I find use cases work very well for that because my brain is kind of top down. And I think it's better to start with some broad strokes or some higher abstraction thinking like, well, what are the tasks we're trying to accomplish? And then elaborate the details over time at the right time, as opposed to collecting this huge pile of information and then trying to organize it and sort it out and say, well, what do I do with this? In fact, I've got a great example of how I've seen that happen. So I've taught more than 200 courses on requirements to audiences of all kinds. And one of the things I do in those courses is I have the students participate in a practice requirements elicitation session after I've described the use case approach. I break the group into 4 small teams, and I see the same pattern over and over hundreds of times now. One of those 4 teams always seems to grasp the idea of use cases, maybe because someone's worked with them before, and they make great progress in that 1-hour practice elicitation session. 2 of the other groups need a little coaching on how to get going with use cases, and then they do fine. But the 4th group almost invariably struggles because they don't try what I'm trying to get them to do, which is talk about use cases. They start in the traditional way of asking the people who are role-playing the users, well, what do you want? And as a result, just like I did with that consulting client, the facilitator ends up with this list of random bits of information that are potentially useful, but there's no structure, no focus, no relationship to what the users are going to do with the system. And I've seen this over and over. Then the team just sort of stares at the flip chart that's got these Post-it notes all over it with these thoughts and feature ideas, and they don't know what to do next. So after seeing that over and over, I think that's pretty well sells me on the usage-centric thinking.
Thanks. And is this something that you just do once at the start, or are you constantly revisiting and revalidating the...
Well, the phrase, you mean on a real project?
Yeah.
Yeah. Well, the term that I use that I think is applicable is progressive refinement of detail. And so I think of maybe doing a first cut to say, let's identify these use cases. Let's take a user group and let's talk about what are the major things you'd need to do with the system. And that's what we did on the chemical tracking system project. And then we can do a first cut prioritization and say, well, which of those are going to be more common or heavily used by lots of people and which ones are going to be more once in a while or only certain users. And that helps you start thinking very early about prioritizing your development approach, whether you're doing it one time through the project or whether you're doing it in small increments. And then you can take each of those based on their priority and start refining them into further amounts of detail to get a richer understanding. And yes, you do have to revisit that as we go along because people will think of new things. People will realize that maybe something someone suggested is now obsolete in our business or whatever. So I think it has to be a dynamic, ongoing thing. But that's why I use the term progressive refinement of detail rather than trying to get that all right away.
Thank you. I'd like to discuss now what you call design. In lesson 18, you state it's cheaper to iterate at higher levels of abstraction. Can you take us through abstraction, prototyping, modeling, designs, things like that?
Sure. So when I'm thinking about higher levels of abstraction, you can imagine a scale where the highest level of abstraction, you've got a concept for a project or a product, let's say. And then as you move down this abstraction scale a little bit, you start talking about requirements and maybe you start doing some prototyping or modeling. So we start progressively moving from concept to something that's more tangible. And at the lowest level of abstraction, when you're building a piece of software, you have code. That's the ultimate reality, of course. But all those things expand as you're going down that abstraction scale. So the idea behind that lesson, that it's cheaper to iterate at higher levels of abstraction, is that it's, first of all, it's nearly impossible to get a design right, that is, an optimized solution, on your first try. At least I can't do it. It usually takes multiple attempts, kind of refining my understanding of both the problem and potential solutions on each cycle. So we want to think of how can you iterate. One way is to write the code over and over, trying to get the solution right. And that's iteration at a low level of abstraction. Or you can try to iterate at higher levels like concepts, the requirements, models, prototypes. And it takes less work to create each of those kinds of artifacts on each iterative pass than it does doing it with code. So you can iterate more quickly and more times. And I think that gives you more chances of getting it right. Has that been your experience, that it takes more than one try to get kind of the solution that you feel best about?
Yeah, I think starting off with design first and then moving into requirements in a project where you have the idea, but things appear as you move forward and then you have to tackle them. And I think that fits nicely with how you say your requirements constantly change as you think about and discuss parts of a project. Your example was the chemical software application. Was that analysis, or what sort of application was it?
It was a tracking system. So it was basically a database application where we could keep track of all the thousands and thousands of bottles of different chemicals, both in the stockroom inventories throughout this very large company and also in individual laboratories, so that we could just order new chemicals, maybe try to find a bottle that's already around somewhere in the company so you don't have to buy a new bottle from a vendor, dispose safely of expired chemicals and that sort of thing. So it was a big inventory system, essentially, with a lot of tracking of individual containers. That's what it was about.
So in the two lessons that we just spoke about, would the design have come first, or the use case of we want to manage and track?
Absolutely,
chemical?
the use cases. Absolutely start with the use cases, because how do I know what to design until I know what functionality it has to provide? And how do I know what functionality it has to provide until I know what people are trying to accomplish with it?
But that's tricky, because the way you can phrase a sentence in English, you could say, I need to design a chemical tracking application, couldn't you? Or you could say, my requirements are a chemical tracking application.
Yeah, so that would be the super highest level of abstraction, right? That's a concept. That doesn't tell you anything about the solution. That tells you about your business objectives, maybe. And I think you do really need to start with an understanding of the business objectives, which is, why do we need to build a chemical tracking system?
Which comes back to the requirements, yeah.
Right. So that's that top level of requirements, are our business objectives, which is really the motivation of why are we spending money and time on this instead of on something else? What's it going to do for us? What financial benefit or compliance benefit or whatever are we trying to accomplish with that? And that, I think, then helps you start identifying your stakeholders, start identifying these user classes. And then I find use cases are just an excellent way to have the conversation initially with those users to say, all right, if we need this system, and one of the big drivers for it was compliance. There were regulations that said, you guys have to report to the government how you're disposing of chemicals and storing them safely and all that. That was our major business driver.
So not just potential commercial wastage.
No, that was kind of a nice side benefit, but the principal driver and the key customer was the guy who was responsible for managing reports to the government for health and safety purposes of how the chemicals were being acquired, stored, and disposed of in the Genesee River. I mean, the cafeteria, wherever they got rid of them.
So yeah, if you didn't do the use cases correctly there, you might go down the feature-centric or the wrong approach, where you think you're trying to save money or you're trying to find something quickly or find out when it's expired, but that's not the top level thing you're trying to do.
That was an important component of it, but it wasn't the key driver. So that's why I think you need this sort of stack of requirements. And that was a big eye-opener for me, is when I realized, there are different kinds of things we call requirements. There are different kinds of things we call design. We need to put adjectives in front of them. And so even having an understanding then of the major tasks people need to accomplish with this that will hopefully achieve our business objectives, you still need to design the software, the architecture, the detailed design, the database design, the user experience design. And I found prototypes were a very good way to help with that iteration. It helps bring clarity to the problem, to the requirements, and to the possible solutions, because it's so much easier for users to react to something that you put in front of them instead of just relying on this abstraction of requirement statements or user stories. So I became a big fan of design modeling and analysis modeling as well. That was another real turning point in my career. You asked about big changes. And that was another big one when I took a class on structured systems analysis and design. And I realized, wow, before I sit down and just start writing code, I can learn a great deal and think a great deal and understand much better if I draw pictures to represent my proposed system or my problem at a higher level of abstraction than just writing code or writing text. And I found that extremely powerful. So I've been a big fan of modeling for a long time because it's a lot easier to change models. It's a lot easier to change prototypes than it is to change a system you think you're done with.
So how do you constantly design something? Do you reach back to what you've just said there, prototyping and proving the idea?
Well, I wouldn't say you constantly design it. I would say you repeatedly design it. And that is, you take multiple attempts to come up with a design that's progressively better each time, and then you build from your best design. I'll give you an example. I have a friend who's a highly experienced designer, and he said, you haven't done your design job if you haven't thought of at least 3 solutions, discarded all of them because they weren't good enough, and then combined the best parts of all of them into a superior 4th solution. So what we don't want to do, I think, is be designing continuously while you're trying to build the application as well. And I think, unfortunately, that happens sometimes. People tend to not think of design as a discrete development stage, a discrete thought process. And people who are building systems hastily in a rush to get them out, like maybe on some agile projects, they might skimp on design. They build something and it works, and we say, okay. But then they are having to constantly redesign what they've done, perhaps, to extend it, to accommodate new functionality. And that's where you have to do a lot of refactoring and that sort of thing, and architectural changes. And I don't think we should use that kind of continuous design and redesign as a substitute for doing some careful thinking before you sit down to write a lot of code.
Yeah, there's a lot you can do up front before your fingers touch the keyboard.
Right. And you're always going to change because you're going to learn new things, and businesses change, approaches and technologies change. So you have to be able to adapt to that. But I don't think the idea of, look, well, we can build code really quickly. We can refactor it for the next iteration. I don't think that should be a substitute for thinking.
And there must be a point where you get so far along that you can't change the design. How do you manage that?
Well, that becomes very expensive, right? And a good example of when that can happen is if people have not done a thoughtful job about exploring some non-functional requirements along with the functionality. And that's one of the tricky things about requirements, is that the part that people naturally think of when you're discussing requirements is the functionality, the behaviors the system's going to exhibit under certain conditions as you try to do things. But we also have all kinds of non-functional requirements, a lot of which are in the category of quality attributes, the so-called ILIDs, right? Usability, portability, maintainability. Some of these are internal to the system, more important to developers and maintainers. Some of them are external and more important to users, like security and availability. But if we don't make that an important part of our requirements exploration, then we can have a problem, just like you're getting at, Gavin, because some of those have pretty profound implications for both functionality to be added and architectural issues. And if you don't think about, for example, certain reliability things, well, in some kind of products where reliability is maybe critical, you may end up building it and saying, oh, this does what we need, but it crashes too often. I can't trust it to, do those communications as we need to. And re-architecting that can be pretty expensive, or sometimes maybe essentially impossible. That's where you get into trouble. So I think the non-functional aspects of the system have to be explored carefully along with the functionality, because you don't just write down, the system's availability requirements on a story card and then patch it in when you get around to it. That just doesn't work.
Thank you. I'd like to move us on to project management. So in our journey, we've got the chemical
tracking system.
Yeah. Sorry. We've done enough user requirements use cases up front to get going. We're potentially starting a prototype and some design models that we've maybe done 3 of and chucked them out and started again. But we're on our way. So we obviously need to manage the project now. So lesson 31 in your book talks about the project team needs flexibility around at least one of the 5 dimensions of scope, schedule, budget, staff, and quality. So I guess that's the 5 things: scope, schedule, budget, staff, and quality. Can you take us through that?
Yeah, this is kind of getting back to it's an extension of an idea that most project managers are familiar with. They've heard of the classic iron triangle, sometimes called the triple constraint of project management. And the colloquial statement of that is, a sign you might see at a gas station when you take your car in. What do you want? Good, fast, or cheap? Pick 2. The idea that you can't have everything that you want necessarily. There's some competition, some trade-offs. And the problem I had with that classic iron triangle is that first, I've seen it drawn in multiple ways with different labels on the vertices. The most common ones are time, cost, and scope on the 3 vertices of the triangle, and we're all kind of familiar with those trade-offs. Sometimes quality shows up in the triangle, but sometimes it doesn't. Sometimes it's sort of in the middle, but I don't know what that means. Does that mean quality is a given so that all the other parameters have to be adjusted to get high quality? Maybe. Or does it mean, well, you get whatever quality you get within the constraints that these other parameters impose? That's not clear. So I was never comfortable with that representation. And so I came up with this idea of these 5 dimensions that you mentioned: scope, schedule, budget, staff, and quality. Now, sometimes people put in risk, but risk really isn't adjustable in the same way that these others are. And the fact is, people do make trade-offs with these against each other, including quality, all the time. People might decide to ship a product that they know is defective in some ways, with the idea, rightly or wrongly, that from a business point of view, it's better to get the product out there fast than it is to make sure that everything works right. Although I don't think customers always agree with that attitude. So I try to also split resources that you see sometimes in that iron triangle into budget and staff, 2 different aspects of resources. I've known of teams that had funding, but they had a head count limitation. They couldn't hire new people, but they could use that money in other ways, maybe outsourcing or buying a package solution or something. So the idea behind this lesson is that there are these trade-offs people have to make and constraints they have to work within if they want to be successful.
Would you say that those 5 things are applicable to whether it's a business application, a hobbyist application, or, because obviously if it's a hobby one, you might not want to spend any money, but the staff level is just you. The quality is as good as you want to make it, and the schedule is as quick as you want to do it. But
right. So that's a little different situation from most commercial or business situations.
But it still sounds like it's applicable, though.
I think it is. I can tell you kind of how this works and why we need to do this analysis of those different dimensions. So I was teaching a class on project management once at a state government agency. And a woman in the class, after I talked about this, raised her hand and she said, all right, so here's our situation. We've got a fixed feature set that all has to be delivered. There can't be any defects. We've got a schedule and it has to be done on time. I can't get more money. The budget's fixed. And I can't get more people, more staff if I need them. So what do I do?
That means none of the 5 are negotiable then.
Exactly right, Gavin. That's exactly the point. And my point is you will fail because if you don't have everything perfect, then you're going to have some limitations here. The first estimate that turns out to be low, someone who decides to leave the company unexpectedly, the first time someone comes along and says, hey, could you add this? Any of those kinds of changes, you don't have any way to respond to them. You need some flexibility around certain of those dimensions. And as you were alluding to a few minutes ago, depending on the nature of your project, certain of those dimensions may not be flexible. They may be constraints. Y2K projects were time constrained, right? That had to be done on a certain date. And that's true of things like, the euro conversion, Brexit. All of those things had time constraints. So schedule was a constraint. You didn't have any choice. So that means something else has to be flexible. So I think of a constraint as being a dimension about which you have no flexibility. The project manager just has to deal with that reality. The second category a dimension could fall into is what I call a driver. And a driver is one of the major kind of success objectives for the project, which may have a little bit of flexibility, but it's important to try to achieve that. And any dimension that's not a constraint or not a driver is a degree of freedom, which has a certain amount of adjustability to it, and the project manager needs to know how much adjustability. So the trick, and this is the balancing point for any kind of project, is to do some analysis so you understand what's critical, what's constrained. Is it schedule? Is it quality, for a life-critical system? We'd probably rather ship it a month late if you have to make sure you don't kill somebody with it. So the project manager has to try to achieve the success drivers by adjusting the degrees of freedom within the limits imposed by the constraints.
So success could be, we have to get it delivered by, the 1st of July. And then you can negotiate around the other 4. Or you might say, we can't hire any more staff, but we're flexible on how much it costs, or, those types of things.
Right. Or you've got a prioritized feature set so that you can say, well, we've got to have these basic features, but beyond that, there's some flexibility in how many more we can include with our fixed team size and our fixed schedule constraint. So you have to know which ones of those are adjustable. And a good way to have that conversation is, suppose you're talking to a manager, a customer, or project sponsor, and they say, okay, this has to be delivered by July 1st. Well, ask the question, what happens if it's not delivered by July 1st?
Yeah, I was going to ask then, who's dictating that? The customer, the internal staff?
Right. So challenge that, or at least inquire about it to understand. I mean, you're not saying no. You're saying, help me understand what happens if we're not done by then. And maybe the answer is, well, we're going to get a fine of 20,000 euro a day because we're not in compliance with some important regulation. Well, that's a pretty serious consequence. That sounds like a constraint to me. So July 1st it is. But what if the answer is, well, we'd like it by July 1st, to go along with our other product launches. But, if we didn't make it out till the 3rd week of July, we can live with that. Okay, it's a success driver, but it's not a constraint. So you need to know which ones are adjustable and how much adjustment there is in there, how much flexibility, so you can adapt to changing realities.
And hopefully some of this has been caught in the requirements stage.
Well, I think it's really part of the project planning stage. And you could understand, I think, that more from a business point of view than from a specific software or solution requirements point of view. From a business perspective, you'll know what's constrained. If you're working in a 4-person company, you're going to be staff constrained, so that limits the size of things you can do in a certain period of time. So I think that's more of a business perspective than a application or requirements perspective.
Is there a common theme you've seen in your commercial training and consultancy?
Well, it varies a lot. I mean, what everybody really wants, I think, is they would like an application that has all the functionality anybody would ever want with 0 defects, instantaneous response time, delivered tomorrow for free. I don't know how to do that. And so obviously we compromise in some of those areas, right? And it's going to vary from situation to situation. But one of the common patterns that I think is one to watch out for is treating quality as a default adjustable parameter. In other words, well, yeah, it's got some bugs in it, but it's Thursday and we said we were going to ship it on Thursday. So we got to ship it because we're done now. It's Thursday. And that I think is short-sighted, partly because, customers don't like bugs. I remember reading an interview once with Bill Gates many years ago when he was still at Microsoft. And the interviewer asked, well, how do you respond to the complaint from users that Microsoft software has a lot of bugs? And the answer was, and I believe this is a verbatim quote, our users don't care about bugs, they care about features. I've never spoken to anyone who agrees with that. So I think too often the default is, well, the quality is whatever it is, and we'll answer the phone if it rings. And I don't really agree with that in every case, but there may be certain cases, like if you're trying to be first to market with a highly innovative project and your target market is early adopter, innovator people, maybe that's okay. So it's a business decision.
Yeah, I'm going to move us on to the next session just so I can keep us on track with time because I want to get a lot covered with you. But just to close off that section, in the network engineering world, the iron triangle, which is the first time I've heard of it, but we call it, you make a choice between fast, cheap, and reliable. So if you're going to buy a router or a router, if you want it fast and reliable, it's not going to be cheap. So I just thought I'd chuck that in there. If we move on to culture and teamwork, so knowledge is not zero sum. This is lesson 35 in your book. In what ways can culture and teamwork positively and negatively impact a software project? For example, the one we're talking about, chemical.
Well, this lesson gets to one of those aspects of how culture and teamwork can affect the project. And let me tell you what I mean when I talk about culture. I think a healthy software engineering culture is characterized by a set of shared values and technical practices that lead to constructive and congruent, that's important, behaviors on the team. And I talk about this in my very first book, which was published back in 1996 and called Creating a Software Engineering Culture. And the willingness to freely share knowledge among team members and to comfortably seek knowledge from your colleagues, that's one of those constructive behaviors. I had a great counterexample of that helped bring this home. I used to work with a guy named Ron. And Ron was older than me. He'd been around a little longer at Kodak. And so I would go ask Ron a question, and I could almost see the wheels in his brain working. He'd be thinking, well, if I give Karl the whole answer to his question, he'll be as smart as me about that. I don't want that. So I'm going to give him half the answer and see if he goes away. So then you come back for another half of the answer, and that's all you get. You want the rest of the answer, you just get another half. So you asymptotically approach getting an answer. And I just didn't appreciate that. I think when we're working together, we should be willing to share what we know with other people. And that positively affects a team because we all do better when we all know more and we all are willing to ask for help or get somebody to look over our shoulder at something. So I think that's a real important way to improve the culture. As another example, in that Creating a Software Engineering Culture book, I described 14 principles that our small software team in the Kodak Research Labs had adopted as shared values. And one of them was that we would rather have a coworker find a defect instead of having a customer find a defect. And as a result, we routinely practiced technical peer reviews of each other's work. It was just ingrained in our culture. We rewarded people who participated in the reviews and who submitted their work to review by their colleagues, but we didn't punish people based on how many defects we found. That would be a real culture killer. Now, if someone joined our group who didn't want to participate in reviews for whatever reason, there's going to be a culture clash, and that just wouldn't be the right place for them to work. So I think having those kinds of factors to steer a culture in a collaborative, effective direction is really critical. And managers play a big role in shaping that culture by helping to establish those principles and values and by exhibiting behaviors that are consistent with those. Have you ever seen a case where management said they valued one thing like quality, but then they rewarded different behaviors, like people who delivered on time without necessarily delivering quality, and then people had to fix it? You ever seen that kind of incongruence?
Yeah, it depends. Two immediate questions that spring to mind when you talk about giving a colleague the full answer and also peer review. Obviously has to be encouraged, and that time needs to be there by the management to allow you to do that. But how do you figure out whether they've put enough effort in for you to justify giving them a full answer rather than just trying to get the answer out of you?
Exactly. Now, that's a good question. And I think you do have to kind of judge, are you trying to get me to do your thinking for you? Or are you just relying on my experience in this particular area so that I can give you an answer faster than you might have dug it up on your own, and probably a better answer based on my experience rather than just whatever you found online? And I think that's a situational judgment. I think in a software team or any team really, we all know who the top performers are. We all know who's coasting or struggling or maybe just trying to get other people to do their work for them. I don't think that's a secret. And if I was working in a team and the same person kept coming to me with what seemed like relatively straightforward questions, things they should already know the answer to, things they should have been able to look into themselves, that's a problem. But if on the other hand, people come to me because I have certain expertise that they don't have and I can impart that, thereby giving them some of that expertise on their own, which they now own forever, we all win. So it is a trade-off decision, but I think in each case you just have to kind of assess the situation and see which of those scenarios we're talking about.
Yeah, you could always ask, what have you tried? And then also judge, well, if I spend a bit more time with you right now, hopefully that'll self-empower you to do it yourself next time.
Right. You're just kind of giving them a start and pointing them. Maybe the help you provide is simply pointing them towards resources and say, look, here's a book I found really helpful, or here's a couple of articles I think will answer your question. Why don't you check those out and then come back if there's something you don't understand? So I think we can handle that in an equitable way without, just ending up doing everybody else's work because you happen to know stuff.
And you mentioned peer review and preferring your colleagues to find issues or bugs. Is that something that, you mentioned management? Do they need to buy into that? How do you do
Totally.
that? if one of your constraints in the 5 constraints of scope, schedule, budget, staff, and quality is schedule, where do you find that time to keep the quality up?
You're raising a very, very interesting and important point here, Gavin. Okay, so let's say our constraint is schedule. And what you're saying is, gee, we've got a certain amount of time, we've got to get a certain amount of work in. And you're saying, maybe your thinking is, well, if I'm on that team and if I spend 2 hours reviewing this person's code or requirements or whatever, then that's 2 hours I'm not spending on my own project to get my work done. So I'm behind schedule. And the fact is that well-conducted reviews almost always pay off more than they cost. That is, the time you spend collectively on a review finds enough defects early enough that you can fix them quickly and cheaply rather than having them get into the final product and have the customer call you later, so that you come out ahead by doing that. Now, if reviews are not effective in terms of actually finding problems, or in that rare case where you don't have any problems to be found, then that payoff doesn't come through. But my experience has been there's almost always a high return on investment from people once they get into an effective review culture. So that's one way to think about it. It's not just what I pay today, it's what I reap downstream by avoided rework because of what I pay today. And the second way to think about it is that whenever you're asked to do something different or extra, your immediate reaction is to think, well, what's in it for me? But the right way to think about it is what's in it for us collectively. And when you start thinking that way, you become more willing, I think, to participate in shared quality activities.
And you could also be using that 2 hour of peer review and you're staring at a bug that you're already working on, or you recognize something that you're doing. So you're actually working on what you're supposed to be working on by helping someone else at the same time.
Yeah, I've learned something from every review I've participated in. And I don't know about you, but I've had the experience where I'm staring at that bug and I just can't see it. And I ask somebody, hey, Jim, can you come take a look at this for me? I just can't see this. And Jim looks over your shoulder. And as you're explaining it to him, one of two things happen. Either you figure it out while you're explaining it, or Jim says, I think maybe this comma's in the wrong place. Oh, that's it. Just didn't see it. Have you had those kind of experiences?
Yeah, sometimes you think what's in front of you and it's not actually there. You've switched that part of your brain off to say, right, I know what's in that part of the project or the code.
Right. You just need a little help from your friends sometimes, and that's
I think we've done a show on
idea.
That, the rubber ducky technique and other things like that. Cool. Right, we've touched on the next section, which is perfect, which is called quality. So, which ties us back into the peer review bit that we've just had a little chat about. So lesson 45 in your book states, when it comes to software quality, you can pay now or pay more later. Is this really true? And how do you define quality?
Well, I think not only is there a lot of data published to support that argument that it costs you more to fix problems later than earlier, but it just seems logical. I mean, the later in the development process, or let alone after it's in production, that you find a problem, the harder it is to debug it, to diagnose the failure and find the underlying fault. Also, the later you find the problem, the more components you might have to modify to correct it. Requirements, designs, code, tests, and so on. And you can get this big ripple effect if you have this cascading series of changes required, maybe even in multiple connected components or systems. So it stands to reason that if you could find, say, a requirement or design error before you've completed implementation based on that piece of knowledge, it's going to cost less to deal with it. So we want to try to find defects as close as possible to the point in time at which they were injected into the development process. And I think that's true regardless of the development lifecycle or methodology that you're following. It's always going to cost more to fix it later than earlier. It's hard for me to imagine how that could not be true.
We need to define quality so we can test it and prove that we've got quality. And that ties us back to the use cases, the requirements. How do we make sure that a use case is of high quality so we can potentially write our test to prove that quality? Maybe it's best explained with an example that you've come across.
Well, the whole definition of quality is kind of a funny concept. And when I was writing this book, I looked up some definitions of software or more generally product quality. And I found a lot of different definitions. They all had merit, but none of them were perfect or comprehensive. So I decided I wasn't going to try to presume to solve that problem and come up with a perfect definition of software quality. But I learned two things from that. One, quality has multiple aspects. You don't just have a 10-word definition of quality that fits everything. Second, quality situational. So I guess we could probably all agree that in the context of developed software, quality describes how well the product does whatever it's supposed to do. And so instead of trying to find the perfect definition, I think it's important for each project team to explore what does quality mean to its customers? How are we going to assess that? How are we going to achieve it? And communicate that to all the project participants. You asked about examples, and I think it's easier to think of examples of poor quality than good quality. So what's poor quality software mean to us? It might mean the products don't let us do the things we need to do. It might mean it doesn't align well with our business processes, and might mean that the product's too hard to use, or it's full of defects and crashes a lot, or doesn't behave the way you expect to, and you get surprised by what it does. Or security holes. There's a lot of ways that you can encounter poor quality. Just last week, I installed the latest Windows 10 update on two of my PCs. Well, really, Microsoft automatically installed those for me. Thank you very much. And both went to nearly 100% disk activity all the time. Never had that problem before. I spent hours trying to figure out what was going on, and that strikes me as a quality problem somewhere. So I don't know about you, but I encounter products all the time that appear to be designed by someone who never used a product of that kind or has some other deficiencies. And that's why I wrote my previous book, The Thoughtless Design of Everyday Things, which shows a lot of the kinds of places we can fall short on quality, even though I can't give you a nice, concise definition of it. But I think each team needs to think about it and then figure out, okay, based on what we think quality means today, what are we going to do to try to lay the foundation for that and ascertain when we're there?
Yeah, I think I've got an example too where quality could be, again, what you've just said. It depends on what the requirement is, what the actual user thinks is important. So a product could get something done in half an hour with no errors. Is that quality? Or they could get it done within 5 minutes with 95% success. That.
Yeah, that might be good enough, but you don't know.
Exactly. One that I found last week was an accountancy software application that we use online for years. And we switched our payment processors. So the screen hasn't, the design, the layout of the page hasn't changed, but the back-end logic has obviously changed because we're using a new credit card provider. But it's as if they've never tested it with someone sitting in front of it. And I'm thinking about the book that you just said. I've seen that book before, and you kindly gave me a copy, where this is out in public and nobody's actually sat down, put in their credit card details and tried to put in a different billing postcode or zip code, like in America. It's using the default one on their system, which might not be where the credit card statement gets sent to, so it's different. I was like, how could they have even done this and someone do that, and then support, because it comes down to the quality issue and, we'll deal with that when it happens.
Which no customer agrees with. No customer will ever agree with that attitude. But
so I have to open a ticket or log into the system, change their main contact address because they want to pay for a credit card, which just, reinforces everything that you've explained with those lessons.
And basically your conclusion is, this is rubbish. Right?
Yeah, so in my opinion, it's not good quality. It's not good quality.
It's not good quality. And, another place I've encountered that is just in the course of my daily life as you're sitting next to someone on an airplane or talking to the cashier in a store or talking to a neighbor. You would not believe how many people have said to me once they learn what I do for a living, said, well, you wouldn't believe this new system we have to use at work. I hate it. They clearly didn't talk to anybody like me before they designed it. And that's a good argument for usage-centered exploration of requirements and designs.
And that's what you've just said, that is the same thing that's happened for the past 50 years.
I know. And that's the thing that's so discouraging. So I know a guy who was he's the guy I consider the father of requirements engineering. And I met him more than 20 years ago. And he told me at that time, in fact, it was about 25 years ago, I knew his work, but I met him. And he said, he stopped teaching requirements classes because after 20 years, he was still saying the same things to people to whom it was all brand new. And he found that discouraging. And I've had the same kind of reaction because I've been teaching requirements classes now for about 25 years. And to me, it's astonishing when I find people that are professional business analysts or developers or software engineers. And I'm talking about stuff that's been known for a long time. and they've never encountered it before. And they say, wow, what a cool idea. And that gets kind of discouraging. So I think there's not been nearly as much progress in those aspects of software engineering as there have in the more technical aspects. Maybe because it's not as much fun or it's not as cool, but it is a little discouraging to have all this stuff still be fresh. On the other hand, it does help keep books sort of viable for many years.
I've been doing programming for slightly over 20 years, and you do see the same things come and go. That's why I think software engineering and the show in general is good, because a lot of our things are timeless. Okay, I'm going to move us on to the last section of the show because we're doing well on time anyway. I'm calling this process improvement, particularly your lesson 51 in your book. Watch out for, in quotes, management by Business Week. What does that mean?
Well, Business Week, I think it's called Bloomberg Business Week now, was a magazine that what's going on in the business world and technology worlds and stuff. And here's the scenario. Suppose there's a senior manager for a software organization and he's taking a flight or, just searching around, and he reads a magazine article or a blog post or a news item about some new software development or project management methodology that promises to bring great improvements in productivity. And the manager thinks, hey, terrific, let's do that and all our problems are solved. So he goes back to work and says, we're all going to do this new methodology because this is going to make things lots better for us. And that is, the manager decides to jump on the bandwagon of whatever hot new approach people are talking about. And I think that's a mistake. So that's what I mean by avoiding management by Business Week.
I do that. A DevOps email comes out on a Sunday, and I always paste links into the group chat. So we should look at this. Yeah.
Yeah, and sharing information is great, but here's what I think people ought to do with that. So let's say it was DevOps, okay? I use in the book, I use a example of a hypothetical method called Method 9, as the example here.
Oh, that sounds good. Let's get a Twitter account for that.
Yeah, and that way we can all be doing Method 9, because what I've heard so far, it sounds fabulous, right? But here's what I recommend. Whenever an organization wants to achieve, let's say, better performance, however you define that, productivity, whatever, I think what you should start with is by asking yourselves, why are we not already achieving that better performance today? In other words, do some root cause analysis of the issues that are preventing you from being as successful as you'd like to be, or understand the cause of some problem. And root cause analysis is a simple technique that can really quickly and efficiently help you identify the real problem. And from that, you can identify approaches to address those specific causes that you think will lead to the improvements. And you might discover that Method 9 is not going to work because that doesn't really address your root causes, no matter how good it sounded and whatever you read. Maybe it doesn't help you break down the barriers that are preventing you from being as successful as you want already. So let's start with some root cause analysis first.
So how do you make time for that if you have got a management structure or a manager that always feeds you these new things, doesn't want to listen or doesn't want to face the facts that things are wrong? Is that an organizational issue, or what suggestions do you have for that type of scenario?
Well, a couple of things. Sometimes it's an educational thing. I mean, there's nothing wrong with being ignorant. We're all ignorant about the vast majority of knowledge in the universe. Being stupid is another harder problem to deal with, but being ignorant's okay. It's a matter of recognizing what you don't know and being willing to learn it. So one thing that we have to do is manage upward in a case like that. And that's a matter of educating your managers, because sometimes the people who are jumping on these bandwagons aren't technical people. They don't really understand the barriers. But if you're in a position of being tasked to say, go buy Method 9 and we're going to all get trained and that's what we're going to do from now on, then I think your responsibility then is to say, well, what is this going to do for us? And how do we know it's going to do that for us? In other words, have we done an analysis, like a root cause analysis, to figure out what our current barriers are and be confident that this is going to help break them down? Maybe it will, but let's do the analysis first. I've never just done whatever my manager told me to do. I want to make sure I understand what we're doing, and sometimes I will try to explain to them why that is or isn't the best thing to do. And maybe you go off and do a root cause analysis on your own even and come back and say, well, we thought about what you said, and here's what we learned. Are you sure this is still what you want us to do? You might win, you might not.
That sounds like some good advice. I've got a couple more questions before we start wrapping up, if I can squeeze them in. Let's just go back to our project management section, because I really like the 5 dimensions of scope, schedule, budget, staff, and quality. If we've got a struggling project So one of those is way off, or a couple of them, they're way off schedule, or this got massive scope creep, or over budget. Are there any quick wins that you could recommend for a struggling project like that?
Well, if there were quick wins that would always work, then I would sell them and make a fortune and buy a very nice house somewhere. But I don't think there's any magic solutions, but I think you do have to get back to understanding why. Good example, scope creep is a perennial problem with many software projects where new functionality keeps coming along. And people keep finding, well, we've got more to do than we thought we were going to have to do. And we're running out of time. But none of these other things have changed. We haven't got more people. We haven't got more money. We haven't got more time. So how are we supposed to make that happen? Well, you can't become more productive by decree or by swapping out your whole team for 90th percentile people or something. You can't do that. So I think you have to ask yourself, why are we experiencing this phenomenon? Are we bad at estimating? Did we not talk to the right users? Did we overlook some key stakeholders and all of a sudden now we found them and their needs are coming in? Very often when you're getting a lot of ongoing scope creep, as opposed to just normal kind of growth, there's always growth and change. But if you find you've got incessant scope creep, you're probably not doing a very good job on requirements elicitation. You're probably missing things, maybe not asking the right questions, maybe focusing on features instead of usage, maybe not doing a good job of prioritization, or maybe not doing a good job of defining the scope of what you're trying to do, and then asking yourself when each change comes along, is this really in scope? You don't just throw it on a story card and put it in your backlog and without doing some filtering first to see if it's the right thing to do. So again, I think understanding why we're experiencing that problem and how that aligns with your business objectives helps you decide how do we respond to that.
Well, my last question, I think you've answered in that one, would be what's the most common issue you see? And it sounds to me like not doing the requirement stage is a pretty big one. Well,
yeah, that's a big one. But I used to years ago be involved with some formal software process improvement activities, like with the capability maturity model or CMM when that was a big thing. And I used to joke because one of the things that was common with those kinds of activities was to do a formal process appraisal where people would come in who were properly trained and authorized and do an appraisal of your organization to see how well you were doing with respect to the expectations of this improvement model and really kind of open the kimono and see what was happening. And I used to kind of joke that I could do a process assessment for an organization remotely for $100. I will send you a postcard and I will write your top 3 problem areas on that postcard. And those areas would always be requirements, estimation, and testing. And those are the areas that I think people had the most difficulty with. There are others, of course, and this is, a little simplistic as a kind of a joke. But I suspect that those are still very common issues that software teams wrestle with. I don't know. What do you see? What are the kinds of things that people encounter in your experience that are chronic, perennial challenges?
I think it's pretty similar. Not getting maybe too excited about the project and cracking on too fast, not spending that time on the requirement stage, sacrificing testing to just doing things in front of them, and not actually automating those tests and using them as a safety net. Pretty standard things that you've explained that you'd be shocked to not think that they've been solved by now.
Right. And, it's kind of funny. There's sort of an unstated mindset among people who are eager. I mean, people, of course, are eager to get into, writing code. I mean, that's what software engineers like to do, is build systems and write code and all that. But there's sort of an unstated undercurrent here that says we have to get started writing code right away because it's going to take us so long to fix it later. Well, maybe if we took an approach to think a little bit more and plan and explore, maybe you're not going to have to fix so much of it later. And so not only is that going to be cheaper, but it's a lot less stressful. And you can probably finish chunks of work quicker than you thought because you're not devoting so much of your effort to rework. That's one of my big bugaboos, is rework. I hate rework. I hate doing over something that was already done. Now, there's always some of that for perfectly reasonable, legitimate reasons. But I think if most organizations took a look at measuring how much of our total effort is spent doing things over that maybe we didn't have to do if we had taken a different approach. Sometimes you might find that you could get a third of your bandwidth back if you did take the time to do some of these other things that lay the foundation and iterate at the higher levels of abstraction instead of on releases And I think you'd probably find that we come out ahead that way most of the time, but it's not as much fun as writing code.
Exactly. Obviously, it's very hard, if not impossible, to distill 50 years of experience into one book. You've done a very good job, let alone one podcast episode. But if there was one thing a software engineer should remember from our show, what would you like that to be?
That's a good question. I tried to, in this book, to put in a lot of the things I've learned from a long time. And I guess one bottom line lesson is that I have never known anyone who could honestly say, I am building software today as well as software could ever be built. And if you can't say that, I think you should always be looking for ways to improve your processes and your practices. So the final lesson in the book cautions, you can't change everything at once. Both individuals and groups, organizations can only absorb change at a certain rate and still get their project work done. So you've asked a couple of times, and how do you do this? How do you get time to do this in a busy project and stuff? And the answer is really, you have to make the time to spend some of your effort on improvement and growth and learning and change and experimenting, as otherwise there's absolutely no reason to expect the next project to go any better than the last project. And one of the techniques that worked well for me is that on every project, I would try to identify one or two areas I wanted to get better at. It could be estimation or algorithm design or unit testing or whatever. And I'd spend some of my time on that project learning about those techniques, looking for opportunities to apply them right away. And you take a small productivity hit every time you do that. It's a learning curve, and there's a price. But if I do that, then in the process, I'm going to improve my own capability for the rest of my career. So I encourage software engineers to adopt some kind of systematic learning philosophy. Always be carving out a certain percentage of your project time, and managers too, in the schedule. Carve out a certain amount of time for learning how to do the next project better. I think that's a real bottom line message.
Thank you. Was there anything we missed that you'd have liked me to ask or mention, or you'd like to mention now?
Well, maybe just one point. These are lessons I've learned, and I think you shared some of those lessons. Were the things there that you said, yes, I've learned that, or no, that doesn't apply to me? What was your reaction?
Yeah, my career's less than half of yours. So some things did have a common theme, but other things were new to me. So I think, a lot of people should spend more time reading all these books. There's so much out there, and there's so much knowledge that flashes past us.
There is. So you've been around a while. You're not exactly a newbie. And so you've accumulated your own lessons about how to do software development more effectively and more efficiently. So I'm hoping that everybody would take some time to think about their own lessons, to share those freely with their colleagues, like I alluded to earlier, help the teams put those lessons into practice, and also be receptive to the lessons that the people you work with have also learned. Basically, you don't have time to make the same mistakes that every software engineer before you has already made. And that's how I learned a lot of these things, is by doing something that didn't go so well and saying, what should I do differently? So I think you can bypass a lot of these painful learning curves, or at least flatten them out, by absorbing knowledge from people who have gone before, which is why I write books like this.
Excellent. My two lessons I've learned are, it's always typos and it's always permissions, whether that's security permission or, business permission. So where can people find out more? Obviously, you're on LinkedIn, which I'll put a link into the show notes if that's okay. How can people get in touch if they want to learn more about your books, your courses, professional consultancy, that type of thing?
Well, my company name is Process Impact, and my business website is processimpact.com. My personal website is, not surprisingly, karlwiegers.com. And there are links at both of those sites where people can send me messages. And there's also links from those pages to other pages or websites that describe some of my books, like Software Development Pearls, The Thoughtless Design of Everyday Things, Successful Business Analysis Consulting, and my forensic mystery novel that you mentioned at the beginning, The Reconstruction. It's the only fiction I've written, and it was the most fun I ever had writing. I just had an incredibly cool idea for a novel. And I said, I wonder if I can write fiction. And other than my PhD thesis, a long time ago, I hadn't written any fiction. So I gave it a shot, and it was just a blast, and had a fun time doing that. So those websites are all accessible from processimpact.com or karlwiegers.com. Plus, of course, you can hear the songs at karlwiegers.com if you dare.
Karl, thank you for coming on the show. It's been a real pleasure. This is Gavin Henry for Software Engineering Radio. Thank you for listening.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.